Okay, children, here we are. We are going to go through step by step the whole nasty chapter 7, 8 review, all the problems. We're going to talk about what they mean, how they work, and all that good stuff. Okay, so we're going to start off with question 1. So at the very beginning, it's a very good place to start. So on each of these proportions, what we're going to do is start off by cross multiplying. That's the cross product property of proportions. So we multiply the top of one by the bottom of the other. So here we're going to get 5 times 5 equals 3 times m. It's going to be 5 times 5 is 25 equals 3m. We're then going to divide both sides by 3. And we're going to get m equals 25 divided by 3 gives us 8 and a third. 8 times 3 is 24. That leaves us with 1/3. 1/3, if I put that into a calculator, would give me 0.3 repeating. So the answer is B. Number 2, start off the exact same way. We're going to start off with 10 times k equals 8 times 5. That gives us 10k equals 40. Divide both sides by 10, and we get k equals 4. Also B. Number 3 is not B, just in case you're wondering. So here it gets a little bit tougher because we have 2 variables involved. So we're still going to start the exact same way, but now we need to remember that when we multiply 6 by x by minus 8, we're going to have to distribute that across. So we get 6x, and then we multiply 6 times negative 8 and gives us 48 equals 3x. Well, normally I like to keep my x's positive. That just requires a bit too much work here, so I'm just going to go ahead and subtract 6x from both sides. And that's going to be negative 48 equals negative 3x. I'm going to divide both sides by negative 3. And negative 48 divided by negative 3 gives me a positive 16. Remember, if we divide a negative by a negative, we get a positive number. So 16 equals x. Moving over to number 4 now. That's C. Here, we go x minus 5 times 3. So that's going to be 3 times x minus 5 equals 7x. Again, we need to remember to distribute that 3. So we're going to go 3x minus 15 equals 7x. Here I'm going to subtract 3x from both sides, and I'm going to get negative 15 equals 4x. I'm going to divide by 4x, and that is going to give me x equals 3 3/4. Negative 3 3/4. 3/4 reduces, or in decimal, is 0.75. So A is our answer. That's the first 4. So if you got all of those right on the test, that'd be 8 points. Okay, so here we are. We have 5 and 6, basically the same. So if we look up here, let's look at 6. We have our short side and our long side there. We have our short side and our long side there. And what we need to do is we need to figure out, we're already told that they're similar, or we need to figure out whether or not they're similar. Say that the triangle pairs are similar. So how we're going to do this is we're going to compare the short side to the short side, the short and long sides together. So we know that if 66 over 88 equals 31 over 40, okay, so if they're proportionately the same, then we know that they're going to be similar. Why? Because this angle right here in the middle, Q, is a vertical angle, and therefore vertical angles are always congruent. So if we have 2 sides that are proportional, then we have side angle side similarity. Notice here, all 3 are side angle side. So we go 66 over 88 equals 31 over 40. 66. Now here, you can kind of shortcut this and go, hold on a second, 31 is a prime number. 31 has no factors other than 31 and 40, which means that that 31 over 40 is the reduced form. So then we can look over at 66 over 88. divide both of them by 11, and see that that's 3/4. Does 3/4 equal 31 over 40? No, it does not. Very close, but not quite. Okay, it doesn't, so A, not similar. Moving on to number 7. Now 7, what we have here is we have two parallel lines, so this is kind of be like a side splitter theorem. And we have two parallel lines there, and we know that when two parallel lines are cut by a transversal, that corresponding angles are congruent. So our transversal is going to be ML, and our two parallel lines are QR and LK. So when ML goes through QR and LK, you have Q and L as corresponding angles. Now notice there, Q and L are corresponding, R and K are also corresponding, and then you've got M, and M is part of both triangles. You've got triangle MLK, triangle MQR. So what we're going to do is we're going to set up MLK right there, and we want to put our M's together, and then second is L, and which one did we say was the same as L? Q. So we're going to put the Q right there, and that leaves us the R as that third place. So it's similar by angle-angle similarity, and it is similar to triangle MQR. Okay, next we have number 8. Number 8, we're looking here and we see, okay, side similarity. Okay, it can't be that. So we can kind of just cross that out right away. Why? Because we don't have information on all three sides. Same thing, angle-angle similarity. Well, we only have those two right there, or those angles right there. We know that H, LHM, and GHF are vertical angles, so they're going to be congruent, but we don't have any information on any other angles. And since you guys don't know the law of cosines yet, we can't figure it out. So we're looking at two things. We say it's either similar because of side-angle side similarity to HML, which means that G and L would be the same, and F and M would be the same, or it's not similar. So here's what you're going to do. 62 is the short side there, 126 is the long side. And so we're going to go 62 over 126 equals 28 over 57. If that's true, then it's similar. If it's not true, it's not similar. So if I just plug this into a calculator, and here's where you can get a little off. If I round it to tenths, I get 0.49 equals 0.49, and I go, yeah, sure, it's similar. But watch what happens when I actually reduce it first. If you look at your calculator, I want everyone to stop, pull out their calculator, go 62 divided by 26, and 28 divided by 57. And what you'll notice is that while the first two numbers are the same, the rest aren't. So if we're rounding to tenths, it works. But watch what happens when I reduce this. I'm going to divide the first one by 2. So 62 divided by 2 is 31. 126 divided by 32 is 63. 28 and 57, well, those aren't the same. Right? So as you can see, 28 and 57 don't reduce anymore. And so we're sitting there and we go, well, that's not true. So honestly, in grading this, I would probably accept both. But the problem is that D not similar is actually true. They're very close to similar. They're similar within 10, 100, or within 100th of each other. But as we move past that, we see that the proportion is slightly off. Okay, so that was 7 and 8. So let's do 9. Now notice 9 require a little bit more work. No longer multiple choice. So we're up in the point value. They're now worth 4 points each. Okay. Now these all require the use of the first and second right angle division corollary, or the rad corollaries. So if you were unfamiliar with this, not sure how they're used, when to use them, I'm not going to stop here in the middle and kind of review all that, but there are videos on my web, on the YouTube channel, which specifically address the first and second right angle division corollaries, kind of where they come from and how they're used. So the first one, we're looking at a leg. So that's going to be the second corollary. Okay, so the second corollary says that the total length of the hypotenuse and the segment of the hypotenuse closest to the leg we're talking about, or adjacent to that leg, have a geometric mean of that leg. So here, total length of the hypotenuse, 25. Our leg is x, and the segment nearest to it is 9. So we're going to go 25 over x equals x over 9. That's going to give us x squared equals 25 times 9, and that's going to give us 225. Now some of you are out there, and we've done this enough, so you go, hey, 225, that's 15 squared. So you can just go x equals 15, and you would be right. Others of you, you're going to want to pop that into your calculator. So moving on to number 10. Now here, notice we have an altitude, so that's the first corollary. The first corollary says that an altitude of a right triangle, the altitude of the hypotenuse of a right triangle, is the geometric mean of the two hypotenuse segments it creates. Again, total hypotenuse here, so we have one segment here and one segment here. So we're going to sit there and we need to find the other segment. We get that simply by going 100 minus 36. So our two segments are 64 and 36. So we go 36 over x equals x over 64. Now again, it doesn't matter which one you put where. Notice if we switched them when we cross multiply, we're still going to be multiplying x by x and 36 by 64. It's going to give us x squared equals 2,304. Just did that in my head, not really. And then we square root both sides, and we get x equals 48. Okay, so now we're going to move on to 11 and 12. Now, if you're feeling particularly observant, a little precocious, you can look at 11 and 12 and go, hey, Mr. Renard, those are the exact same triangles from 9 and 10. We got the 64, the 48, so the other one, and we've got the 15 and the 9. So I know that proportionally all these have to be the same, so I'm just going to kind of jump to it and go, notice there, so we have 15s in both places. Remember, x equals 15. So we have a 9 there, which means the other one has to be 25, so you can just kind of skip to it and go x equals 25. If you're not feeling so spunky, what you can do is you can go ahead and actually work that problem out. 15 times 15 is going to be 225. 9 times x is 9x, and then we're going to divide both sides by 9, and we get 9 equals, or x equals 25. 9 equals 25 would not only be an incorrect answer, it's just incorrect, period. 9 doesn't equal 25, 9 equals 9. Or no, if you're speaking German, but that's a different 9. So here again, we can look at the two triangles, and when we set it up, we know, see here, x equals 48. So when we set this up as the altitude being the geometric mean of the two segments, then we see that that 64 is there, that 48 is in the same place, so we could really just kind of sit there and go x equals 36. How we'd solve that, though, is we're going to go 48 times 48, and we get 2304 equals 64x. We're going to divide by 64, and we're going to get x equals 36. Now again, the key to these problems is really pattern recognition. It's being able to look at the triangle, see that what happened was we took a right triangle and drew the altitude of the hypotenuse, and realizing when that happens, that we're probably going to be using the first or second corollary. If the numbers you were given, now both of them use the hypotenuse. The first corollary uses the two hypotenuse segments. The second corollary uses the entire hypotenuse and the segment closest to the leg. And you can see that this would be the second corollary right there. And these both use the first corollary. So once you get to that point, you go, okay, well, I know that they both use the hypotenuse. What other information am I given? If I'm given the measurement of a leg, that's a leg of the original right triangle, it's going to be the second corollary. If I'm given information about an altitude, whether it's the actual altitude or just a variable as the altitude, then that means that I am going to be using the first corollary. Okay, so as you can see right here, I skipped, so give me just a second. I'll pull up the right one. We're looking for 13. And there it is. Just got a little bit out of place. Okay, so 13 and 14. So these, now we're moving past the corollaries, and we're starting to talk about our, our similarity rules. Now we had three basic similarity rules. We had the angle bisector, the triangle angle bisector theorem, we had the side splitter theorem, and then we had the corollary to the side splitter theorem. Now we went over this, and you were given specific examples of each and told kind of which one applied to which. So 13, again, if you don't understand this, there's I think like a half-hour long YouTube video on it, which I really break down all of this. So 13, okay? 13 is going to be an angle bisector. And so when a ray bisects the angle of a triangle and hits the other side, it divides the opposite side into two segments which are proportional to the other two sides of the triangle. So what that means is that first we need to figure out what we're going to call these two segments right here. Okay? And we're going to call them x and 6 minus x. Why 6 minus x? Well, because if the entire thing is 6 and the small part is x, then what's left is 6 minus x. Like if I said it's 4, then the remaining part would be 2. If I said it was 1, the remaining part would be 5. So we're going to set that up as 8 over 6 minus x. Okay, so these two right here, because those are what the triangle angle bisector theorem says are proportional. And we're going to say that that is equal to, because remember that's all a proportion is two equal ratios to 4 over x. Now there's only going to be one number that fits that. So we're going to go 8x, and that's going to equal 4 times 6, 24, minus 4x. Then going to add 4x to both sides, and I'm going to get 12x equals 24. Then going to divide by 12, and I get x equals 2. Are we done? No, because see what the instructions say? Find the missing length indicated. So we're going to take that 2, plug it back in. We could actually plug it back into both. And so we get question mark equals 2. If we plug that 2 into 6 minus 2, we get 4. So we know that it's actually 2 and 4, so that works. Same general idea with 14. We're going to start off and give our question mark an x designation. We're then going to sit there and say that the other portion of that is going to be 14, the total, minus x. So then we're just going to set up our proportion. 14 minus x is to 5, as x is to 2. And this would be the corollary of the side splitter theorem. From there, we're just going to go ahead. We're going to go 2 times 14 minus x equals 5 times x. That gives us 28 minus 2x equals 5x. We're going to add 2x to both sides. And we're going to go 28 equals 7x, or x equals, and then we're divided by 7 and we get x equals 4. Alrighty, onward and upward. So that was 13 and 14, so now we're looking at 15 through 18. These were 3 points each. Now on each one of these, what we're doing is we're starting off, you should be starting off with your kind of base ratio of everything. Remember 45, 45, 45, 45, 90 triangles are, the base ratio is 1, 1, square root of 2. 30, 60, 90 ratio, have that base ratio of 1, square root of 3, 2. So, that's 1, 1, square root of 2 there. Ratio times the scale factor is going to equal the final one. So here, we know that that's that those are the sides that they're opposite. So here, the square root of 2 is opposite of 45. So we're going to put square root of 2 there, and we ask ourselves, what exactly times 1 equals the square root of 2? And we promptly answer, why self, it's the square root of 2. Now remember, if it's the scale factor for 1, it's got to be the scale factor for all 3. So then we go 1 times square root of 2, and we also get square root of 2. And then we go the square root of 2 times 2, the square root of 2, which gives us the square root of 4, or 2. So u then is going to be the square root of, or u, which is the hypotenuse, is going to be 4, and v is going to be the square root of 2. 16, also a 45, 45, 90 triangle. Same deal, 1, 1, square root of 2. I'm going to skip writing out ratio, scale factor, and final. But we know that 5 square roots of 2, because it's opposite a 45-degree angle, is going to be in one of the 1 spots. We go self. What times 1 equals 5 square root of 2? We answer ourselves and we go, you know what, self? You're being kind of silly, because anything times 1 equals itself. So if you want to make 1 into 5 square roots of 2, or 5 radical 2, you multiply it by 5 radical 2. And if it's a scale factor for 1, it's a scale factor for all 3. So then we go 1 times 5 square root of 2, and we get 5 radical 2. And then we go 5 times the square root of 2 times the square root of 2. And back here, see how square root of 2 times square root of 2 equals 2? We go 5 times 2, and that equals not 20, but 10. Okay, now 17 and 18 are both 30, 60, 90 triangles, which means that the base rate is going to be 1 square root of 3, 2. And that is, the 1 is opposite our 30-degree angle. The square root of 3 is opposite our 60-degree angle. And the 2 is opposite our 90-degree angle. So here, that we're given is that square root of 6 over 3, and that is opposite the 90-degree angle. So that's going to be our hypotenuse. So then we sit there and we go, okay, well, what times 2 equals the square root of 3? And self says back, well, that's not quite as easy. So we set up our little equation. We go 2 times the scale factor equals square root of 6 over 3. We then divide both sides by 2, and we get the scale factor equals the square root of 6 over 6. So if our scale factor is square root of 6 over 6 for 1, it's square root of over 6 for all. Now, the top one's pretty straightforward. 1 times square root of 6 over square root of 6 is just going to be y equals the square root of 6 over 6. Second one, a little bit trickier. Square root of 6 over 6 times the square root of 3 is going to equal the square root of 18 over 6. Now, I specifically told you there are 2 roots that I want you guys to be familiar with, and that is the root of 12 and the root of 18. The root of 12 turns into 2 root 3, and the square root of 18 turns into 3 radical 2. So right, that is 3 radical 2 over 6, 3/6 reduced to 1/2. So we get square root of 2 over 2. And that would be the answer for number 17. Moving on. 18, a little bit easier. We have 1 square root of 3, 2. That's our base. Ratio. Scale factor goes in the middle. And the final goes on the side. Now here, we're looking at what's opposite the 60-degree angle. So that goes up in our final under the square root of 3. So we sit there and we go, hey, kind of gave it away there. Hey, what exactly times the square root of 3 equals 6 times the square root of 3? Well, it's 6. And again, if it's true for one, it's true for all. So we go 1 times 6 equals 6, 2 times 6 equals 12, and we are done with that problem. Again, I believe there is a YouTube video on this. So again, if you're looking over this, everything's making sense. You go, yeah, I can do this. Yeah, I can do this. That's great. If you're looking over this and you're like, I have no clue what just happened, go back, look at the other YouTube videos, learn it. Okay, so now we should be going on to, I'm going to quick do that to show you how I got 6. See, 6. I think we're going to go on to number 19. And here we are. Sorry, guys. 19 through 22, 2 points each. Why? Because all you're being asked to do is find the value of each trigonometric ratio. You're not being asked to find a missing angle or a missing side. All you need to identify is exactly what cosine, tangent, and sine are. So, we have cosine of z. So for z, now we should know that cosine is adjacent over hypotenuse. Right there, see? So for z, the hypotenuse is going to be 50. Why? Because it's opposite the 90-degree angle. The adjacent one is 48. Why? Because adjacent means next to. Remember, if we're talking about east coast, west coast, we go, okay, it's 14. If z is on the west coast, is the adjacent one going to be 48, or is the east coast going to be 14? Those are both true, actually. So we sit there and we go, east coast is 14. It's on the opposite side of the triangle. That makes it opposite. Adjacent would be like San Francisco. It's right next to the coast. Okay. So we're going to go adjacent over hypotenuse, 48 over 50. Both of those can be divided by 2, and we get 24 over 25, or 0.96. Either one of those is fine. So if you just want to go 48 divided by 50 in your calculator and say that the cosine of z equals 0.96, that's fine. And that's it. And that's why it's only worth 2 points. Because all I have to do is set up that ratio and either reduce it or punch it into your calculator. Tangent, opposite over adjacent. So we have z again. Opposite z is that 20. Adjacent to it is that 21. Why? Because again, we're talking if z is LA, then the east coast, 20 is opposite it. West coast, 21 right next to it. So tangent equals opposite over adjacent. So you have the tangent of z equals 20 over 21. 20 has factors of 2, 4, 5, and 10. 1 and 20 as well. 21 has factors of 7 and 3. 1 and 21. So no reduction. And that's it. If you want to put it into decimal form, it turns out 0.95. Number 21, the sine of A. Sine, opposite over hypotenuse. So we go sine equals opposite over hypotenuse. So the sine of A, we go, hey, if A is, what is opposite A? Well, that's 9. And the hypotenuse there is 41. 41 is a prime number, so there's no reduction there at all. So 9 over 41 is a perfectly legitimate answer. If we then wanted to actually plug it into our calculator, we get 0.22. Okay. So, finally we have tangent of x. Very similar to the one directly above it. Tangent is opposite over adjacent. So we go, what's opposite the x? Well, that's 16. Adjacent is 12. Tangent equals 16 over 12. That is going to give us 4 over 3, or 1.3 bar. Okay? So on those ones, 19 through 22, same numbers on the actual test. All you're being asked to do is find the ratio. You don't need to find out what the angle is. You don't need to find out what the third side is. All you need to do is find the ratio. Okay. Here, 23 through 25, find the measure of the indicated angle to the nearest degree. 4 points each. Okay, looking at those points, you go 4 points each. Probably going to be a little bit trickier. So here, we're going to start exactly the same as what we did before. And we're going to say that, okay, so here's our mystery angle. And we know that we're either going to be using sine, cosine, or tangent. So we're given of our mystery angle the opposite side and the adjacent side. So we look up and go, hey, O and A, that's tangent. So we know the tangent of mystery angle, let's call it x, equals 15 opposite over adjacent 19. Okay, now you need to remember that for what we're doing, there's a one-to-one relationship between an angle and its sine, cosine, and tangent. So one of the ones that we did, first of all, was that the sine of 30 degrees is 1/2. And for what we're doing, the only angle with a sine of 1/2 is 30. There's that one-to-one relationship. So you have a calculator there, and you're being asked, so now I'm going to show you how to ask your calculator, hey calculator, what angle has a tangent of 15 over 19? And you have to understand that the answer is going to be the only angle that has a tangent of 15 over 19. So we go tangent of x, 15 over 19 reduces to about 0.789. And then this is what you're going to do on your calculator. You're going to hit shift or second tangent. You're then going to hit shift dash. Now for most of you, if you're using the graphing calculators in the classroom, that dash is right above the number 3. It has answer in blue, I believe, right above it, and that's actually what you're doing. When you do that, what your screen will show is this: tangent to the -1 power, open parenthesis, answer. And what that command is going to do is tell your calculator to look through all its data banks and say which angle specifically has the tangent of 15 over 19. When you hit enter, it's going to give you 38.3. So that's rounded to the 10th. We look at our directions, and it says round it to the nearest degree. So we're going to get rid of that 0.3. If you don't get rid of that 0.3, I'm not going to give you full credit. Okay, you guys need to read the directions. You need to follow the directions. If I ask for the nearest degree, I want the nearest degree. If I ask for tenths or hundredths, I want tenths or hundredths. Okay, 24. Here we have opposite and the hypotenuse. So we look up, we go so, ka, toa. So ka, toa, so ka, toa. Which one is it? Well, which one has the O and the H in it? Well, that's sine. So we're going to go the sine of x equals 22 over 25. Same exact thing, except now we're going to be doing it with the sine instead of the tangent. So the sine of x is going to be approximately 0.88. We're going to go shift or second sine, shift or second dash, and that is going to give us 61.6 or 62 degrees. Third one, number 25. Here we have opposite and adjacent. So again, that's going to be tangent. So we have the tangent. Why do I smile? Because we seem to be using tangent a lot lately, so you guys should be really familiar with it. We have the tangent of x equals 5 over 10. That means the tangent of x equals 1/2. So then we're going to hit second or shift tangent, second or shift dash, and that again will give us tangent -1 answer. We hit enter. So we're asking our computer what exactly, what angle has a tangent of 1/2, and it says, why, Mr. Renard, it's 27. Okay, so that's how you find a missing angle. A lot of you guys said that you had difficulty with this. So if that doesn't make sense, go back, watch it over 3-4 times if you need to until this makes sense. 26. Same thing. We have an angle on the side, and again, it's sine. How do we know? Because we have opposite and the hypotenuse. So we know that the sine of x equals 38/41. We're going to hit sine of x equals 0.93. So then we're going to hit second or shift sine, second or shift dash, and that is what our screen will now look like. Sine of the -1 answer. We get equals, and we get 68 degrees. Again, it's actually 68 point something or 67 point something, but because the question told you to round up to the nearest degree, that's what we're doing. On to 27. If I'm moving too fast for you, you have the power to rewind it. Some of you may be extremely happy. You have the power to mute me, which is the only time you'll ever have that power. Okay? So use that. Go back. Watch it at your own pace. Go step by step. If a step doesn't make sense, rewind it. Watch it a couple times. If it continues not to make sense, try and figure out what doesn't make sense about it. So when you can come into class, you have a very good question. Mr. Renard, I was looking at number 26. I didn't understand. I understood that 38/41 equals 0.93, but I just don't get really what that inverse sine, or what is called arc sine, actually means. Come in with that question, and I'll be able to sit there and go, well, and I'll explain it to you. Coming in and going, I don't get number 26, and then I start from the beginning and you getting frustrated, not as good. Okay, 27. Same general idea here, okay, except we're looking at the sides. So here we're given 63 degrees. We are then given the side opposite 63 and the side adjacent. Now 63 has a specific tangent. So we know that the tangent of any angle is going to be opposite over adjacent. So we know the tangent of 63 is going to equal 18 over x. Now there are two ways to do this. Okay? We can sit there, and my preferred way is to switch the x and the tangent 63. But that's also, again, I do this all the time. That makes a lot of sense to me. If you look at that and go, I have no clue what happened, don't do it that way. But you're going to get x equals 4.1, and it's actually 9.1, I think. I wrote it wrong, but I'll go back and change it later. The other way you can do it is you can actually hit tangent 63 into your computer or into your calculator, or 63 tangent, depending on what you use. And it's going to give you 1.96. So we can then go 1.96 equals 18 over x. We can multiply both sides. We can cross multiply. So we get 1.96 equals 18. 1.96x equals 18. We can then divide by 1.96. And we get x equals 9.2. Okay? So notice we're going to get the same answer either way. You just need to figure out which way works best for you. 28, we have the hypotenuse and the adjacent side. So that is cosine. Cosine, ka, in SOHCAHTOA. Ka is cosine, is adjacent over hypotenuse. So cosine of 73 equals 17 over x. 17 adjacent, x is the hypotenuse, x is what we're looking for. So I'm going to switch those, 17 over cosine of 73, or I can go 0.29, because that's the cosine of 73, equals 17 over x. Multiply both sides by x, I get 0.29x equals 17. Divide by 0.29, and I get x equals 58.6. Now again, if I just hit 17 divided by cosine 73, I get 58.1. Now notice because I'm rounding, I end up with a slightly different number. Okay, it's going to happen. Don't worry. As long as you show your work, I'll know that you're doing it right. If you don't show your work, I'm not going to know what you did, and I'm going to assume you're guessing and may not give you full credit or any credit at all. Okay, from 28, we're almost done, guys. See, show work. We got we're going to jump ahead, 13, 14, 15. And we're going to go to 29 and 30. See, just 2 left. Well, 2 left and then the word problem. So we have 29 and 30. So again, we have 64. We have opposite and adjacent. Tangent. Tangent is opposite over adjacent. So we go, the tangent of 64 is going to be x over 11. Now notice in the other two, the x was in the denominator, a little bit more difficult. Here, x is in the numerator, a little bit easier, because all we have to do is multiply both sides by 11. Right? So we go 11 times tangent 64, which is 11 times 2.05, and we get 23 degrees. For number 30, we have opposite and adjacent. Hey, tangent again. Woohoo! And we get tangent of 27 is going to be opposite 16 over adjacent, back to x being in the denominator. So we're just going to switch. So we go 0.51. I'm going to do it the other way now. Tangent of 27, put that into my calculator. I get 0.51 equals 16 over x. Multiply both sides by x, and I get 0.51x equals 16. Divide by 0.51, and I get x equals 31.4, or 31. I actually think it is 31.4. I think on these we were asked to. It's not actually a degree. It's just 23. So these, you'd actually want to make sure you kept that 10th. And finally, 31. Now notice 31 is the word problem. Notice the picture's worth 4 points, and then finding the angle of elevation and angle of depression are worth 5 points each. Why? Because it's a little bit harder. Word problems are tougher, so I give them more points. So, here is Andy Angle. Looks like he had a little bit of hip surgery. Poor Andy. Andy is flying a kite. And that kite is directly above Tommy Tangent, who apparently says he's juggling, but he must be juggling while kneeling because he's really low to the ground. And that is 135 feet. We were told that the angle of elevation, that's from the ground up to the kite, is 63 degrees. We're also told at that same time, a pair of coconut-laden sparrows are flying over Andy at a height of 72 feet. Yay! We are unaware of their airspeed velocity, laden or unladen. So, what we are looking for is and we know that they're flying at a height of 72 feet. And we're looking for that angle of depression there. Okay? Not a very pretty picture, but there you go. Still a picture worth 4 points. So I'm looking for that angle of depression, x degrees, and then y. So these are my 2 triangles that I have. I have the triangle between the bird, Andy, and Tommy, and then I have the triangle between Andy, the kite, and Tommy. Like so. And notice in each one, I know exactly what I'm looking for. So I got my picture, check. Now, once I've done this, it's exactly, now that I have my picture, it's exactly the same as doing the problems above. So, both of these are going to use tangent. We know the tangent of 63 is going to be whatever y is, that's the height of the kite, over 135. So we're just going to multiply both sides by 135. We're going to get 135 times the tangent of 63 equals y. And that's going, the tangent of 63 ends up being 1.96. So we go 135 times 1.96, and we get the kite is flying at 265 feet. We now need to know the angle of depression. Now keep in mind, we talked about this before. Notice that what I circled here is that x right there. And the reason is, when we look at this, we should remember that the angle of depression, which is the angle from the flying object on an imaginary horizontal line, is the same as the angle of elevation from Tommy to the two coconut-laden sparrows. So as we're looking, we see that the angle of elevation and the angle of depression are alternate interior angles. If you remember back to chapter 2 or 3, alternate interior angles are congruent when a transversal cuts through two parallel lines. The horizon and the imaginary parallel line going through the bird are parallel, and that's why we can do this. So we know that here the tangent of x equals 72 over 135. That's opposite over adjacent. So we know that 72 divided by 135, we're going to hit equal, and that's, see that 0.53 bar? That's what's going to show up on your calculator. It actually might just show up as 72 over 135, but that's actually, they can both be reduced by 9. But it's going to be 0.53 bar. You're then going to hit second tangent, and when that happens, this will pop up, tangent to the -1. You're then going to hit second dash, and then it's going to go answer. And when you hit enter, you are asking your calculator to tell you what angle has a tangent of 0.53. And you hit equals, and it's going to tell you that it is 28 degrees. So the angle of depression from the birds to Tommy is 28 degrees. I hope you guys found this at least somewhat informative and helpful, other than just getting all the answers, because while getting all the answers will help you get some points on the review, it won't actually help you solve anything on the test. So have a lovely night, everybody, and I'll see you guys tomorrow.